This is part 6 in this series devoted to Improv Card Magic. Now today we will be looking at 16 card packets, 16 cards. And so to begin this, what we will need is 3 random piles of 16 cards each. Now this is going to use up most of the deck, as you might imagine. So I'll go ahead and just deal them out, 3 piles of 16 each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Whoa, look at that. Just 4 cards left over, which is what we would expect. Okay, so we have these 3 piles of 16 cards each. Now, I do want to review something that we talked about in the previous video in which we looked at 14 card packets. And so this is a little system that I came up with to essentially make remembering color pairs easier, okay? So for example, let's say we lay out the cards, and from the top of the deck we have a red, 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 black, 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 and so forth, all the way to the bottom card, which happens to be black, okay? Now if you remember my system, what you can do to quickly remember how many red pairs you have and how many black pairs you have, and we're going to ignore the color pairs that don't match. So for example, right here we see 2 red cards together. Okay, so if we view this as an AMP, these 2 cards would be, quote, related. So what we can do is we will count a red pair as 10 and a black pair as a 1. So that when we add all of these values, the tens place will simply tell us how many red pairs we have, and the ones place will tell us how many black pairs we have. So for example, we have a red pair here, so in your mind think 10, nothing here, and we have a black pair, so that counts as a 1. So 10 plus 1 is 11. Another black pair, so plus 1 is 12. So just keep a running count. Plus 10 more for a red pair. So now we have 22 as our number. Nothing, nothing, plus 1 more, 23. So the only number, or the only information we would need to remember until the end of the performance is the number 23. And then when we go to use that number, we'll look at the tens place, which is a 2, and that will tell us that there's 2 red pairs, and the ones place, which is a 3, and that would tell us that there are 3 black pairs. Okay, so we'll kind of use this little system for remembering how many color pairs we have. Okay, now let's come over here and we'll take a look at this packet. This really is a random packet. And now we're free to look at it as a mirrored or a 2-cycle, because those are the 2 that are left. Okay, we'll assume that our AMP is kind of taken here. We've spent that one. That one's already covered. Okay, so how are we doing here for a mirrored structure, let's say? And anything, oh, this is interesting, just kind of a quick glance here. These are the same value. That's kind of interesting. Anything that just screams out is like super, super surprising. Well, a couple of things I noticed. Of course, we have 2 sevens. That's kind of interesting. We have 2 hearts here. Not much of interest there or here. But these are both clubs, both red, both 6s, and both hearts. Wow, there's a fair amount going on here, but that might be a lot to hold on to, all of that different information. So for this one, why don't we go ahead and use our system here, okay? So remember, we're looking for colored pairs. A red pair counts as a 10. a black pair counts as a 1. Okay, so there's nothing here. But here's a red pair. So think 10, nothing, nothing, a black pair, so that's plus 1, so we're up to 11. A red pair, so we add 10, we're up to 21. Nothing there. Another red pair, 31. Okay, so if in your mind's eye you want to just remember the number 31, that's all that you would need to hold on to, just 31. And then you just, of course, need to remember how to decipher the information contained within those two digits, 31. And of course, the 3 here tells us how many red pairs we'll have at the end, and the 1 tells us how many black pairs, and then all of the other pairs are guaranteed to be of opposite color. So I think that's fairly strong, actually. Okay, so now this is a mirrored packet relative to the characteristics that we made note of. Do you remember the number that we associated with this one? I believe it was the number 31. Let's just check that. I believe that's the case. The number 31. Now, do you remember what that is supposed to tell us? The tens place tells us how many red pairs there will be at the end, and the 1 tells us how many black pairs. Okay, well, we'll find out if that's right. But before we get there, we're going to give the spectator a chance to just mix these cards to wazoo here. So since this is mirrored, you know that we have the stay stack principle. And so that allows us in particular to deal into 2 piles, left, right, with random stacking decided by the spectator. So maybe they'll stack left on right, that's fine. So we can do that because 2 is a divisor. It divides into 16, okay? Well, 4 divides into 16 evenly as well. So we can deal into 4 piles, left, right. And we can stack from left to right or right to left. My more advanced students know that we can do even more than this. We can also do, and I'll go ahead and just do it, it's called a leapfrog stacking. So you pick up this one and it leaps over its neighbor and lands on top of the 3rd pile. This one here, pile 2, leaps over its neighbor and lands on top of the 4th pile, and then you can randomly stack these. Okay, so you could have done a stacking from left to right, or from right to left, or a leapfrog from left to right, or right to left. Isn't that interesting? Okay, so let's go ahead, and so this is still mirrored. That's the key. So we've done both of those actually. This is still mirrored. Well, we can convert it to an AMP by way of this LR to the negative R. Now, if you take a look at line 23, on the chart on the left, you'll see that we can convert a mirrored structure to an AMP using this very special dealing. Okay, so how this works is you deal out into 8 piles. It's half the number of piles as you have cards. So it's like 1, 2, 3, 4, 5, 6, 7, 8. Now, normally what we would do is deal out the rest going 1, 2, 3, follow that same pattern. Well, the LR to the negative R says, okay, instead of repeating the order in which we do it, we go backwards now. This next one goes on the last one dealt, going backwards. Okay, that's all. It's the R in the exponent is meant to remind us of the word reverse. So you reverse the order in which you deal them. Well, what that will do is it actually gives you, quote, a DMP, actually. Okay, and I guess I left that out, but you can freely stack these pairs in whatever order that you like, actually. You can stack these however you like. So this is, quote, a DMP. So you can have the spectator tell you, like, which ones to pick up. Maybe they want this one next, and then this one down here, this one way down there, and then this one, okay? Now this is a bona fide AMP, okay? So it really, really is. Okay, now a shuffle that we can perform on an AMP, in the case of 4N, cards, so a multiple of 4, which is what we have 16 cards. If you look at line 6 on our table on the left, it's called a supercoat. And if you notice there, under structure preservation, next to supercoat are AMP structures, as long as you have 4 N cards, which we do. So a supercoat, how does that work? You just deal out half the cards, 1, 2, 3, 4, 5, 6, 7, 8, set the other ones down, and now the spectator is free to stack the left pile on top of the right or the right on top of the left. It doesn't actually matter. It won't hurt the fact that it's still an AMP. Isn't that amazing? Okay, and now we can convert this to a 2-cycle, kind of like we did over here. Now, why don't we do it a little bit differently this time? Because we have this plus J. J is for judicious. So what that means is, in contrast to what we did back here, where we just did left, right, left, right, left, right, we can actually Klondike into 4 piles. You can go 1. So I'm taking the top and bottom off as 1. It's Klondike shuffle. And then we're setting them down into 4 piles. Okay? So this is an alternate Klondike into 4 piles. Oh, I'm sorry about that. I lost the middle one there. There you go. Okay, and so now we can stack these from left to right or right to left. We can actually do the leapfrog stacking if you want. So if you want to go from right to left, the leapfrog stacking would say, okay, this one leaps over its neighbor and lands there. This one leaps over its neighbor and lands there, and then you can randomly stack these. Maybe we'll go left on right. All of those decisions can be decided by the spectator. And what we're guaranteed to have now is a 2-cycle. Okay? Now you know that once you have a 2-cycle, you can do random cuts. You know, we're going beyond what I've written here, but it's on the table. Or you can do Charlier shuffles to your heart's content. You can do as many of these as you like, okay? None of those will hurt the fact that it's a 2-cycle structure. To go from a 2-cycle structure to a mirrored structure, we can actually perform the Bessie 2-2. Now, I do need to point out something special here. So if you look at line 16, the table on the left, the Bessie 2-2, it will convert a 2-cycle to a mirrored structure only if you have a multiple of 4 cards, which we do here, right? So this is wonderful. So what we can do is, so Bessie 1-2-2, remember, is where you take the top card off. You do that kind of like twice. So you go 1, 2 from the top. Try not to drop these. 1, 2 from the bottom. Okay, 1, 2 from the top. 1, 2 from the bottom, 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top, 1, 2 from the bottom. Okay, so that is a Bessie 2-2. I apologize for these cards being brand new and slippery here. So this is guaranteed to be a mirrored packet now. Well, once it's mirrored, you can do a whole bunch of stay stack shuffles where it leaves mirrored structures alone. One of them is the up jog. It's line 11 in our table on the left. So you can be an even up jog or odd. I think you'll find it easier to do an even up jog. This is where you jog forward the even position cards like this, and then you just strip out the ones that are jogged forward, and then you can randomly stack just straighten that up, randomly stack these according to the spectator's request. It is still mirrored. We can even deal into 8 piles if we would like. So you can go like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And now we can do a stacking from left to right or right to left. You can do the leapfrog, which works great. It's just it'll be, well, should I be brave here? I don't know how much I should show you here. What you can do right here is you can stack those on top of those, actually, and then stack from left to right, right to left, or even leapfrog from there. Should we be brave and do that? Okay, so in this kind of situation, you can actually do this. Isn't that amazing? Okay, and then why don't we just stack from left to right? You could do right to left, or you could even do the leapfrog there as well. Isn't that amazing? Okay, so the hope is we haven't destroyed the mirrored structure, and we'll find out if we did in just a moment, right? And then finally, let's do a LR negative R. We did that near the beginning. It's going to give us, quote, a DMP. So this is where you go, very similar to what we just did, by the way. 1, 2, 3, 4. 1, 2, 3, 4. Do you remember what that little negative R exponent means? It means you go in the reverse order now with dealing them. The second level is dealt out in the reverse order. What does that do for us? These are the exact pairs that we made note of at the beginning. That's what is guaranteed to happen here. Okay, so why don't we, I'm just going to move that pair up there. Doesn't matter how we order these here. Okay, maybe we'll go like that and like this. Okay, so we can see them all, quite well. We have 8 pairs. Now, do you remember the number that there's just one number we needed to remember for this mirrored routine. It was the number 31. You remember that? I can show you here. Well, I don't know if I can without having the cards slide everywhere. Hopefully you remember that. Do you remember that? See 31? Yeah, there it is. Okay, so 31. Well, what is the 31? Well, we wrote down 31 because the tens place, which is a 3, is denoting the fact that we have 3 red pairs. Somewhere in here we have 3 red pairs. And then we had 31. And then the 1 is denoting the fact that we have 1 black pair somewhere in here. Okay, so we have 3 red pairs and 1 black pair, assuming we haven't made a mistake along the way, right? And I don't believe we have, but we'll find out, I guess. Okay, so, and then you can spin this in a number of ways. So at this point, you would just state, well, I'm getting the impression that 4 of these are of opposite color. There's just opposite colors within the cards. And then 3 of them are red pairs. 1 of them is a black pair. Let's see if that's true. So is it true that 4 of these are of opposite color? Well, there's 1 opposite color. And are 3 of them red pairs and 1 black? Oh, there's 1 red pair. Maybe we'll focus on the red and the black just to see. Oh, oh boy. Oh boy, that's a bit scary. I claimed that there's only 1 black pair. That's all I felt here. So none of these other ones better be black pairs. Otherwise, the universe is going to blow up here. Okay, well, there we go. There's another red pair. So we're up to 2. I sense that we had 4 of those, actually. Oh, those are opposite, so that's okay. We thought there'd be 4 of those. Oh, here's another one of opposite color. Okay, so what do we still need? We need 1, 2... Oh, yeah, we just need 1 more red pair for this to be correct. And no black pairs. If we have a black pair, we're dead. Oh, look at that. Opposite color. And so, boy, talk about the cliffhanger. This needs to be a red pair for our little intuition to be correct here. I'm sorry about that. I'm pulling up the little pin. That's red, and that's red. We nailed it. There's 3 red pairs, 1 black pair, and 4 pairs of opposite color. And we didn't make a single mistake. How could we actually accomplish that working together?